This is 2014 FRQ number 6 on the non-calculator section. My problem got cut off a little bit. Consider a differential equation dy over dx equals 3 minus y cosine x. Let y equals f of x be a particular solution to the differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. A portion of the slope field of the differential equation is given above. Sketch a solution curve through the point 0, 1. So you kind of see this curve kind of goes down, up, and then down, kind of like a trig function, right? It has to go through 0, 1, so let's mark that point first. 0, 1, nice and clear. And then so you just kind of draw a curve that kind of goes through that point. That's it, nice and simple. All right. Part B, write an equation for the line tangent to the solution curve in part A at the point 0, 1. Use the equation to approximate f of 0.2. So same as always, find the tangent line. We need the slope. Well, we have the slope. Slope is up here. All right, so slope is equal to dy over dx equals 3 minus y. So 3 minus 1. Cosine of 0. All right, so that's 2 times 1. So that's 2. Okay, perfect. So now part B, I'm going to work down here. Part B, the equation is y minus 1 equals my slope of 2 times x minus 0. If I clean this up, y equals 2x plus 1. So my linearization, right, that's what they really want. Linearization is 2 of x equals 2x, L of x equals 2x plus 1. Okay, use that to approximate 0.2. So L of 0.2 equals 2 times 0.2 plus 1. So 0.4 plus 1, that's 1.4. So the approximation is about 1.4. Okay? Find y equals f of x, a particular solution to a differential equation with the initial condition f of 0 equals 1. Again, this means solve for the original function, right? So if my slope is dy over dx equals 3 minus y cosine x, separate your variables. Move your y over, move your x over. Dy over 3 minus y equals cosine x dx. We'll take the integral of both sides. So this is, again, a natural log function because you have dy over y to the first power. So natural log of 3 minus y. But don't forget chain rule. There's a negative in front of the y, so it's negative out here. Integral of cosine is sine x and then plus c. All right. So remember, at this point, the minute you have your plus c, you want to plug in your initial value, which is 0 and 1. So 0 for x, 1 for y. So negative natural log of 3 minus 1 equals sine of 0 plus c. Negative natural log of 2 equals c. Okay, so now what do? I put it back in again. Always back into this one right here where the c first popped up. So negative natural log of absolute value 3 minus y equals sine x minus natural log of 2. Okay, so first divide by negative. So what the negative does is when there's a subtraction, it just switches these around. So it's natural log of 2 minus sine of x. Then to get natural log, you get e on its own. So 3 minus y equals e to the natural log of 2 minus sine x. Now, if you want to split this up a little bit, it's really e to natural log of 2 times e to the negative sine x. That's 2e to the negative sine x. It's a lot cleaner. All right. So which one is it? Because it's absolute value. So absolute value says that 3 minus y could equal positive 2e negative sine x, or 3 minus y could equal negative 2e negative sine x. So how do I know which one? Plug in 0 and 1, right? So if I plug in 0, what do I get? Plug in 0, 1. So I plug in 0, 1. I get 3 minus 1 equals 2e to negative sine of 0, 0. So 2 equals 2. Good. What about this one? 3 minus 1 equals negative 2e to the 0. So 2 does not equal negative 2. So this is my final answer. So 3 minus y equals 2e to the negative sine x. So I'm going to use this to solve for my final y. So subtract the 3. I get negative y equals 2e negative sine x minus 3. Divided by negative 1. Like I said, if it's a subtraction problem, it switches over. So 3 minus 2e to negative sine x. And that's your final answer.